matter is one of distinct forms in which matter can exist. Three states of matter are observable in everyday life: solid, liquid, and gas. Matter in the liquid state maintains a fixed volume, but has a variable shape that adapts to fit its container. In particles are still close together but move freely. Matter in the gaseous state has both variable volume and shape, adapting both to fit its container. Its particles are neither close together nor fixed in place. Matter in the solid state maintains a fixed volume and shape, with component particles, atoms, molecules, and ions close together and fixed into place.
One day you and your friend ate ice cream together. Suddenly, the ice cream fell. Oh no, what should we do? We can make our own ice cream using the states of matter that we learned earlier. The equipment you need for this experiment is
a bowl to mix your ingredients, sugar, vanilla extract, thermometer to test the temperature, milk, salt, ice, sprinkle, one large and one medium zip-top freezer bag. For safety, remember to wear warm gloves to protect from the very cold ice water. Let's start it. First, pour 1 tablespoon of sugar. Next, pour 1 cup of milk. One teaspoon of vanilla. Pour the mixture into each of the medium freezer bags. Squeeze any extra air out of the bags and seal them tightly. Fill your larger bags halfway with ice. Add all of the salt, select to one. In the other, do not include salt. From observation, the thermometer shows ice with salt rising 2 degrees Celsius. Ice without salt 5 degrees Celsius. Place one of the filled smaller bag inside and zip it. Let's invite our friend to help us. Now let's shake. You can add more ice if you need to. And shake again. Let's check which bag makes the best ice cream. As we can see, the bag with ice and salt give you good result. Yes, we are successful. So, you probably wonder why the bag with ice and salt give good result than the other bag without salt.
When we increase the temperature of a substance, we are adding energy in the form of heat into the substance. Once the amount of energy added to our substance equals the substance melting point, the molecules with enough energy begin to spread apart and transition from a solid state to a liquid state. When we add salt or sodium chloride into our ice, it separates into sodium and chloride ions. The more salt we add, the more it affects the freezing and melting point of our ice. Basically, salt lowers ice melting point, which means that it changes from a solid to a liquid at a lower temperature. Similarly, when we add salt to the ice for this recipe, the ice melts more quickly. When things melt, they put heat from their surroundings. The faster the ice melts, the faster it pulls heat away from the half and half mixture, causing it to freeze.